Hello everyone. Welcome to our new event. Today's topic is boiler, operation, maintenance, and efficiency. Boilers power industries, generate heat, and keep our world running. But have you ever wondered how they work, why they fail, or how efficiency can be maximized? Welcome to a deep dive into boiler operation, maintenance, and the science behind their efficiency. Chapter 1: The Heart of Steam. Understanding boilers. A boiler is more than just a metal tank. It's a high-pressure vessel designed to convert water into steam. But not all boilers are the same. Two main types of boilers. 1. Fire tube boilers, simpler design, used in small to medium-scale applications, think locomotives and industrial heating. 2. Water tube boilers, more efficient and suited for high-pressure industrial use, think power plants and marine applications. Engineering note: water tube boilers can handle pressures above 2000 psi, making them ideal for high-capacity power plants. Efficiency isn't just about burning fuel. It's about design. A poorly designed boiler wastes heat, money, and energy. Chapter 2: Boiler Operation. Optimal performance. Operating a boiler effectively requires knowledge of its components and how they work together. Key elements include 1. Burners. They mix fuel with air to create a combustion process that generates heat. 2. Heat exchanger. This is where the heat from combustion is transferred to the water, producing steam. 3. Controls and sensors. Modern boilers are equipped with advanced controls that monitor pressure, temperature, and water levels, ensuring safe and efficient operation. To maintain efficiency, it's essential to regularly calibrate these controls and perform routine checks. Chapter 3: Safety First. Avoiding disasters. Boilers operate under extreme conditions. Without proper safety measures, they can be ticking time bombs. Major safety risks: 1. Overheating, caused by low water level or poor circulation. 2. Excessive pressure, can result in catastrophic explosions. 3. Corrosion and scaling, weakens metal over time. Engineering note: the most famous boiler explosion in history was the Sultana steamboat disaster, 1865, killing over 1,100 people due to poor maintenance and pressure buildup. Key safety measures: 1. Pressure relief valves, PRV. 2. Automatic water level controls. 3. Regular inspections and ultrasonic thickness testing. Chapter 4: Efficiency. The science of saving energy. Efficiency is not just about numbers. It's about cost savings, energy conservation, and sustainability. Boiler efficiency formula: direct efficiency. This method calculates boiler efficiency by using the basic efficiency formula. ETA equals energy output divided by energy input into 100. In order to calculate boiler efficiency by this method, we divide the total energy output of a boiler by total energy input given to the boiler, multiplied by 100. Calculation of direct efficiency. E equals Q, H minus H, divided by Q into GCV, into 100, where Q equals quantity of steam generated, kilogram per hour. H equals enthalpy of steam, col per kilogram. H equals enthalpy of water, col per kilogram. GCV equals gross calorific value of the fuel. Ways to improve efficiency: 1. Proper air-fuel ratio: too much air, you lose heat. Too little, you get incomplete combustion. 2. Condensate recovery: reusing steam condensate saves fuel. 3. Blowdown control: reducing unnecessary blowdowns prevents heat loss. 4. Adding an economizer: preheats feed water using exhaust gases, improving efficiency by up to 5 to 10%. Design note: modern boilers now use AI-based monitoring systems to auto-adjust fuel and air ratios for peak efficiency. Chapter 5: Maintenance. The difference between profit and loss. Regular maintenance isn't just recommended, it's critical. Key maintenance tasks: 1. Daily, check pressure, temperature, and water levels. 2. Weekly, inspect for leaks, test safety valves. 3. Monthly, blowdown sediment buildup, inspect burners. 4. Annually, conduct deep cleaning, ultrasonic thickness testing, and efficiency tuning. Engineering note: a 1 mm layer of soot on boiler tubes can reduce efficiency by up to 5%. Cut to a time-lapse of a technician cleaning tubes, showing the impact on efficiency. Final Chapter 6: The Future of Boilers. With advancements in technology, the next generation of boilers will be smarter, safer, and more sustainable. Future innovations: 1. AI-powered boilers, self-adjusting efficiency algorithms. 2. Hydrogen-powered boilers, zero-emission alternative. 3. Supercritical boilers, operating at extreme pressures for 50% plus efficiency. Final thought: boilers aren't just about heat. They are about innovation, sustainability, and keeping the world running. Now that you know the science behind them, what's your take on the future of boiler technology? Thanks for watching. If you enjoyed this video, please don't forget to like, comment, share, and subscribe to support the channel. Hit the bell icon so you never miss an update. Share this video with your friends, it really helps us grow. Keep me in your prayers. See you in the next one. Coming soon.